Hello, and welcome to Exploring Global Problems, a podcast where we talk to academics from Swansea University whose groundbreaking research is tackling global challenges, from health innovation to sustainable futures and the environment, from digital technologies to clean energy. My name's Sam Blaxland, and today I'm joined by Dr. Emily Preedy, a researcher from the School of Engineering at Swansea University. Her research explores minimising the effects waste gases have on the environment. Emily is working on using waste carbon dioxide to help grow algae that can clean up waste fumes from local industry. Emily, welcome to Exploring Global Problems. Good to see you. Could you start us off, please, by telling us just broadly about your research?
We've got a project called RICE, which is reducing industrial carbon emissions. There's several work packages, so it means different projects within the bigger project. My work package is work package 2. So me and my team are looking at growing algae, which is just like a plant, likes growing in a liquid environment and uses up carbon dioxide, which we know is a massive problem at the minute. So the algae use up carbon dioxide and give off oxygen, which is amazing. That's what we want. But it also produces protein-rich products at the end. So hopefully we could sell some products and get everyone healthy with protein supplements at the end too.
So multiple things you're doing all in one go. Taking it down even to its very basic fundamentals, what are some of the big challenges that you face which actually is spurring on your research?
At the minute, we've all heard about climate change and all the global effects and Extinction Rebellion, which they all have important points to make. We've all known in school about global warming, and it's the same issue, too much carbon dioxide, and us as humans are the worst for doing it, with our cars, travelling. So why not combat against it? Algae, plants, we need houses, we need to live and have a normal life. So this is just one way of attaching to industry that's already there so it doesn't impact on our day-to-day life. So it should be an easy addition to any industry around you, whether it's large or small scale. Just shove some algae alongside it and it'll grow.
Where do these waste gases come from? The ones that we're worried about?
Well, everyday things. Opening up your can of Coke, that produces carbon dioxide. Using a hairdryer produces carbon dioxide. You're travelling to work, if you drive, produces carbon dioxide. But the main culprits are industry. They've got their big flues and chimneys producing lots of waste emissions. So the aim of this project is to use as much of those waste emissions as possible by producing other useful items or storing it for later use or making something else out of the carbon.
And which industries are we talking about? Because obviously we're here in South Wales, famous historically for coal. We don't have a coal industry in this country anymore. So who are the culprits?
There's a few local industries that we can use. At the minute, there's probably 3 or 4 different industries. So metal producing industries or cement industries. They also produce a lot of carbon dioxide. So that's mainly who we're looking at. We've also worked with a farm down in Plymouth who use they use waste plastics to produce energy, but obviously that a lot of carbon dioxide comes from that. So we've been harnessing that carbon dioxide to grow algae down there as well.
One more general question, and then I promise I will ask very specific things about the algae. We hear about our carbon footprint.
Yeah.
It's quite a common thing. What exactly do we mean by that? And what are, in general, practical ways to reduce it?
I think this is a thing the government should be thinking about and give out, leaflets saying steps 1 to 10 of how you could reduce your carbon footprint. So that I suppose the notion of carbon footprint is how much of a trace are you leaving behind? So you could think of it like when you get out of a bath and you leave footprints on the floor of water, we leave footprints everywhere of carbon dioxide. So how could we reduce that? Simple little things. Put an extra jumper on in the house rather than turning up the heat in an extra degree. Don't dry your hair with a hairdryer. Leave it dry naturally. Obviously nicer in the summer. You could sit out in the garden, let your hair go blonder. But I don't think there's been enough push on what everyone can do individually to make a bigger change then for longer term, because people don't want it to impact on their day-to-day life. So don't use a straightener. Just dry your hair naturally.
And I guess critics would say that, we are used to life and living standards improving.
Yeah.
Generation upon generation. And if I want to turn the heating on rather than wear a jumper or straighten my hair, that's something I should be able to do. But you reckon we've got to rein some of this in?
I think we need to rein a lot in, unless you have a brand new built house and you've got solar panels and you've got all these other alternative power sources that most older properties don't in this country. And I think a lot of research needs to go into developing technology to help these older properties come up into standards, insulating your house, little things like that would help reduce your carbon footprint as well. But obviously it's a lot of money, whereas maybe there could be some technology that could be improved to put into houses.
Okay. Right, which leads us on to talking about your specific research and the rice project. So how can you use waste carbon dioxide to grow algae?
Well, algae are just like plants. So just like any house plant you've got uses carbon dioxide because it photosynthesizes. So as everyone knows, I think photosynthesis uses light and carbon dioxide to produce oxygen and energy to help them grow and develop. This is basically the aim. So we use sunlight in the summer months and artificial light in the winter months because obviously we're light limited in this country. But hopefully we could use solar panels for our light in the winter because you still do get some UV rays. So basically growing algae like a normal plant, but in a liquid environment instead of just in a pot on a windowsill. So we're going to have a greenhouse. We're building a massive, it's called a photobioreactor. So it's basically a lot of tubes, like if you think of big straws, and they'll snake. So the algae will be growing and moving along this like little snake of tubes, see-through, because obviously you need the light to penetrate through the plastic. And we've used plastic, not glass, because they'd be too heavy and I don't want to drop them and break them. But at the end then, we should get this like green goo product that you can harvest. So basically like harvesting on a farm with bales of hay, you're going to take all the product and dry it out. And then hopefully use that as supplements then for food or animals. And
yeah, and you say you hope to do this. So are you in the relatively early stages now, and these are the ambitions to make the project, the idea much bigger?
Yes, yeah, we've basically just started out. So we've already built one down in Plymouth. We've been out to Belgium to build a photobioreactor out there as well. So all of them have the same basic principles. Some are larger, some are smaller. We're hoping to build 2 5,000 litre reactors. So we've got it all ready to go. We're just waiting for the AOK off the industry that we're hoping to go into. And then it's basically just set up the algae. So we've got some flasks and things downstairs growing algae. So it's like bubbling away. Very relevant for Halloween. Green pots of
slime.
Yeah. Slime. That's all it looks like at the minute. But hopefully we'll be able to upscale that and produce it at a very large scale. So 5,000 litres is a lot. You could use the tanks that we've got as swimming pools.
Wow. And how does this then relate to the cleaning up of the waste fumes from industry?
So basically, we're going to be like a hoover, sucking off the carbon dioxide and attaching it to our photobioreactor.
What's that? What's a photo?
So
whatever you just said.
Yeah, the photobioreactor. So that is just the plastic tubes and the straws.
I see, sorry. Okay.
So that is, I suppose it's a bioreactor because there's something biological inside that's reacting. But the photo side is that we want the light to be producing the product.
Great. And you talked about this being implemented in Plymouth to begin with.
Yes.
So you've got a team that you're collaborating with down there.
Yeah, we work along bioscience. So they're on the Singleton campus. So they initiated that project. So as the engineers, we got to do the building, got our spanners out, lovely overalls. But it was nice down there in the summer because the greenhouse is very warm. But they also produce a lot of food products on this farm. So we got to eat a lot of clotted cream.
Oh, fantastic.
Yes.
It's worth going to Plymouth.
It
just
was,
for that.
Yeah.
Now, you've won some funding, haven't you, from Women in Engineering?
Yeah, I recently won that. It's only about £2,000. That's a nice little pot. So aiming to work with other engineers in the project, mainly females. Some of the men are going to help as well, bless them. And it's to build a smaller version or demonstration model of what we're trying to do in the rice project and trying to link each project together to show how they all collaborate and work together.
How do you envisage this project panning out in the long term? What would your real hopes and goals for it be?
For the women in engineering one?
Oh,
or
no, I was
rice?
thinking, the rice, the overall thing.
Overall, it would be lovely if it was successful and you could easily implement it into other industries, even attaching it to things like the university, using up their carbon dioxide and producing something at the end. It's a win-win for everyone, because if you can produce sort of high value products at the end, then the profits can go back into each industry or hospitals or anything like that. Anything that's got waste carbon dioxide or waste fumes, it could be attached to.
And presumably you'd like this to go global, because it's all very well, like you say, doing it here, isn't it, at Swansea University at one place. That's going to be a tiny sort of part of trying to solve a bigger problem. You need other countries and governments to really latch onto this too.
Yeah. So at the minute, we've also worked with Belgium. So they're building, we've built a photobioreactor there for them as well. But there's lots of little projects going on all around the world, but a lot of them are open ponds. So that's slightly different to our bioreactor. So the open ponds get more contamination. You can't control the growth as much. The light can't penetrate down, because it is literally, when you go to a country park and you see all the green over a pond, it looks a bit like that. So it's not as controlled environment as we've got. You could say we're forcing ours to grow because we'll be controlling the light that it gets. But it would be an easier and cleaner way of attaching it to industry than some of the other techniques that are used currently.
Ask a very specific question now about algae and why it's important, but also its properties. Because I've read that you said it's got more protein than tofu, more calcium than milk, and more iron than spinach.
Yes.
Now, that's all fascinating in and of itself. But why are those facts useful?
Well, Popeye should have known about it, so he could have eaten it instead. I think for centuries, seaweed has been eaten. So it's the same family as seaweed. It's just a smaller version. And I think it's important to know those properties, because you can make useful products out of it. So our aim is to sort of manipulate then the product. So if you give it more light, you might get more protein out of it. If you stop the light, it might produce more carbohydrates, which are all useful in health food supplements, for animal feeds, dietary supplements. So if people aren't getting enough iron, you can take it. You can already buy some in the shops. Spirulina, it's often sold in health food shops. But you also, there's pigments in some of the like chlorophyll and things like that. Well, the blue Haribo sweets, that comes from an algae.
Really?
Yes. So there's little things like that we're going to try and see how much we can produce. Can we get high yields? Could we manipulate it in certain ways to produce more? Almost like artificial selection with animals, that what algae would grow best in this climate. So there's all little tweaks and things that we can do then to get these supplements out.
Do you think algae might have a bit of an image problem? Because in terms of using it for scientific research, because when you say it, you think something that, like you think of murky pond, as you spoke about.
Yeah.
Does that, is that a slight barrier to get people to realise how important it is?
I think it's a barrier if you try to get people to eat it. I think it's that the yuck factor, isn't it? Of, do I really want to try that?
Yeah.
I don't know whether working with it, I've worked with lots of different materials over the years. I think this is one of the nicer ones. So I think as scientists, we're used to prodding and poking lots of things. So I suppose for the general public, maybe we need to break down some barriers and go, it's green, but it's nice.
I'm sure we'll come back to it, because it will inform lots of other parts of the discussion that we have. But I've read that you've also worked with human stem cells.
Yes.
Now, how does that feed into this kind of research?
Well, I'm a bit of a jack of all trades. So my PhD was looking at the mechanics of human stem cells and how they interact with nanoparticles that would come off hip implants. So I think I've adapted how I grow human cells to how you can grow plant cells. So they basically You give them the right nutrients, you give them the right media to grow in, and they'll grow. So that's how I've sort of gone down this route.
What does that actually practically involve, the hip things that you were talking about?
So you always get wear and tear in the hip joints.
Mm-hmm.
So basically you get little particles that are like foreign particles of metal in your body, and your body will react to these foreign particles. And that's why a lot of hip implants fail, and you have to have a renewed one probably within 5 years, usually, of having a hip implant. So it was just a way of looking at how those cells change, and could I coat the metal in anything to stop these issues from happening, stop bacteria attaching, which also help break down the metals, which you don't really want. So it's a big impact on the body, really, having something foreign inside. But the way the mechanics of the cells change is that they kind of get harder around the implant, so you could lose mobility in that way. So it was testing different metals to see which had the less impact, which metal would be the better metal to put in the implant.
And did that then help inform the stuff you do on the algae, or are they completely separate projects?
Well, algae actually clean up metals, so you can use it in wastewater treatment as well.
Oh, tell us more about that.
It's kind of similar. So like our cells in the body, like a Pac-Man, eat anything, which isn't good sometimes, but then you fight against it. Similar with certain algae, they'll be like a Pac-Man and they will eat anything, which sometimes that's why they're attached to wastewater treatment. So that's another industry that we could go into, depending on which algae species we pick.
What's the potential there?
Well, there's a lot of wastewater treatment. There's the major one, Dŵr Cymru in Wales. So potentially, if this is successful, we could approach them in the future. It could be a long-term plan, or any wastewater around the world. If you're looking at cleaning up mine water, could be another potential there as well.
What about you then, Emily? How did you find yourself here at Swansea University? What's your background? How's your career progressed?
Gosh, well, in school, always loved science, so sort of like the natural route. And I think where most people think they want to be a medical doctor. So that was me starting out. Mm-hmm. I wanted to be a medical doctor without realising there's so much more to life than just that. So obviously I didn't get my straight A's. I had a few successful interviews to get into med schools, but didn't get the straight A's at A-level, thinking, oh my gosh, life has ended. What do I do now? Had a placement in Cardiff University to do biochemistry, and then thought, I don't really want to do that. So I phoned up clearing at Glamorgan and did forensic science, because I thought, well, I may as well do something I'll enjoy. And that was such a good background of knowledge and different fields of science. It went from biology, extracting DNA, to looking at how nuclear magnetic resonance works, how you can use analytical tools to find out what set a fire. So it gave me a good background in a broad range of sciences. I then thought, I don't want to give up uni yet. I quite like it. Looked around and found a master's in nanomedicine here at Swansea University. So that kind of opened up the doors to engineering, because it was more engineering-based sciences.
Yeah, what's nanomedicine?
Well, basically, small medicine, no. It's looking at things like cells. So that's how I ended up doing my PhD then, with the stem cells. So it was looking at that. Just looking at the small physics of things, and how you can go down from, like, now this is the macro scale we're at, but how does the smaller scale affect the big scale? What little things could you change? So like your mobile phone, they keep getting smaller because it's nanotechnology that's now in the phones. So how we can make things more efficient, maybe at reducing the size or improving the technology. So that was the nanomedicine, with a sort of looking at nanotechnology, but with a side of medical and biology aspects, which I really liked biology. So I thought, that's a good course to go on, and thoroughly enjoyed it. And it was fully funded by the EU, so I couldn't complain.
And then what path led you to the algae research?
Well, I suppose after my PhD, like most of us who finish, you end up doing a lot of postdoc work. Mm-hmm. So I moved on to a few sort of like medical projects. One was looking at how you could fight infection. Then I ended up back in Swansea University looking at continuous blood glucose monitors. As a diabetic, I was like, that is an amazing project to look at. And then after that, I wanted to get back to growing things because I did like working with my cells when I was doing my PhD. So looked around and found this job and thought, that sounds like a good one and very relevant to what's going on now.
Did you say as a diabetic?
Yes.
You type 1?
Yes, I am.
Oh, interesting. Yeah, so you've got the implant on your arm.
Well, no, I don't have that.
No.
I'm still stabbing myself.
Yeah,
But,
doing the finger prick test.
Yes, yeah. I'm not quite keen on having the continuous monitor yet.
It's a fascinating piece of technology, though, isn't it?
Definitely.
Yeah. Can you explain to us how it works?
Well, it's definitely the way forward. So basically, the reason why I don't fancy it is they tell you there's no needle in it, but it's a probe that just goes under your skin. So that then detects the glucose in the blood. So instead of pricking your finger, you don't have to do that. But you can only keep it on for 2 weeks because as anything in your body, it's still a foreign object. Mm-hmm. All the cells are going to attach to it and it's going to lose its sensitivity. So I think until that technology is a bit better, I don't want it.
Speaking as a scientist as well.
Yes,
that's interesting. Yeah. Anyway, so you see that there is this project with Rice. Have you been with Rice since its beginning or did you join it a little bit later?
No, since the beginning. So it started last year, yeah, which is a lovely idea as a postdoc that you can see a project from start to finish. Because usually you start halfway through or you're here to help out with your skills or expertise and your knowledge and you dip in and out of different projects. But this one was lovely because it was basically building things from scratch and get to use a spanner.
Get to use a spanner in terms of constructing these greenhouses, etc.
We do actually build stuff as well, which is lovely because I think as a scientist, you're used to your white lab coat, the gloves on, which is nice that we actually go out on the field and get to do some physical work as well. It's like having Lego or Connects again, but it's on a larger scale.
And you said you were attracted to it as well because it was relevant.
Yes, definitely. With everything that's going on, I think we need to be thinking about our future and generations ahead, that we do need to clean up our act, basically. And a lot of research has been going on throughout the years, but no one seems to have been listening. So I thought this was a real, in the moment, get to grips with what's going on, and this could help.
Are you optimistic about the future and about these sort of things, A, working, but also being taken up by the people who it needs to be taken up by, i.e. governments around the world?
I think if we can show this is successful and get some good papers out of it and good data, it would definitely be worth then trying to, you could implement it in policy change. The industry have to have something green alongside their technology. I know a lot of companies do want to go green and have a neutral carbon footprint. So I think this is another step forward, and I think it will work as long as people are forward thinking and they don't think, oh, well, we've got to put a lot of money into it before we reap the rewards almost.
And what would you say to critics who might argue that it's all very well doing this in the UK, but actually there are developing nations in the world who are continuing to open, loads of coal-fired power stations, for example, probably not with many green considerations in mind. So actually we can do all we want, potentially at a hit to our economy, and it won't make a big global difference.
Well, I think as long as we're researching it here, maybe we could then improve the technology so it wouldn't be as expensive to implement in these other countries. But part of this project is also using waste heat. So if you are burning coal, you can still use the waste heat to produce electricity. So there's other renewable sources that could be implemented alongside just growing algae.
So it's a hope that others follow our lead.
Yes, definitely. And I think if this is successful, and it should be, then it could be implemented anywhere.
Obviously, the driving force for you, the underlying motive, is a reduction in carbon production.
Yeah.
How can people practically reduce their carbon footprint?
Simple little things. If you can, cycle to work or to schools. Try to use public transport where you can. I know we don't all like it because we can't rely on it, but it is better for the environment. Simple things like eat less meat. That's got a massive impact, and that's not just the carbon, that's the methane that goes into the environment. Like I said earlier, put an extra jumper on rather than turning up your heating. Just be more active in sort of little things that you do each day, rather than, if you think small at the start, then it'll help with the bigger problems.
I know we kind of touched on this before, but I think, I'm a historian, and from that perspective, I often see that when people are not really incentivized to do things, they're not going to often do it voluntarily, and they'll do what's easy.
Yes.
So they either need to be incentivized or told to do things, and sometimes that actually ends up being quite illiberal.
Yes, yeah, we don't want to be a nanny state, really, do we? But I think sometimes with these bigger issues, I think the government should be stepping in and giving us a guide to how we can be greener and what we can do in our houses. Maybe even simple things like growing plants in pots in your gardens or on windowsills. If you haven't got a garden, get some more allotments. Let's be green. And maybe it's going back a few steps, sort of back to basics. But if that helps with the environment and gives us a longer future, then that's what we should be doing.
And of course, pots on the windowsill in the kitchen is also a nice thing, hopefully,
exactly,
to
yes,
look at.
Yeah.
But I guess critics again might say that this is tiny little things, isn't it, for a big global issue? Surely it has to be more radical than that.
I think the only radicalization would come from the bigger industries globally, and until they want to change their ways, even as individuals, if every person just changed one or two things about their day-to-day routine, would make a massive impact on the carbon that we release.
So what other groups and organisations do you work with on this research?
So we work alongside the University of South Wales. They've got a work package within the RICE project as well. They're looking at bacteria and how bacteria can clean up carbon or waste products from industry. We also work with, some of the colleagues, they're working with hydrogen. I think there's a big stigma behind that of it's just going to explode, but it's a useful energy source and could potentially be in our homes alongside our gas sort of cookers and things. We work with the University of Ghent. So that's why we went out to Belgium, and bioscience as well. They're the experts in the algae growing.
So this involves international travel as well and collaboration with people overseas?
Yes, yeah, it's some of it, which isn't always green.
You could maybe see which way I was going here, just to sort of follow up my theme of my previous questions. But yeah, is there a concern there?
Personally, I think there is. When we travelled over, we all went by car because we had to take tools with us. I think that was more economical as there were three of us. But I do think a lot of the times with conferences and things, it's handy to meet people in person so you can network. But I think sometimes why can't everybody sort of, go Skype interviews and do more of this type of collaboration work? Maybe that's the way forward instead of actually getting on a plane and going out to these countries. Sometimes it's essential when you need to get a rapport with people. But often if you are just there to give a lecture, couldn't it be done through something like Skype?
It is the irony sometimes, isn't it? Or it seems to be that the bigger the global issue, and often when we're talking about sustainability and global warming, you often find the people who work in that area do the most travel.
Yes, yeah, which is a bit silly, and they do need to share their ideas, but conference calling, that works just as well. Why? Maybe that needs to be a government policy that unless it's essential travel, you shouldn't have to do it.
Can I just look at this whole topic just from a slightly different angle, which is to say that rather than trying very hard and putting a lot of money and resources into combating climate change, perhaps there's an argument for almost working with it and innovating to try and mitigate the problems when they happen, things like flood defences, dredging of rivers, etc. Well,
yes, you could plug money into that, and it's almost just putting like a plaster over a wound, isn't it? It doesn't solve what's underneath, and it might not be the right type of plaster for the wound that you've got. So I think prevention is better than cure. So if we could prevent more damage to the environment, I think that's the way forward rather than just fixing the issues as and when they arise. Flooding is going to keep happening. If the temperature keeps rising, we're going to have more water. Like Attenborough says, with, everything's going to melt, the water level's going to rise. Having more flood defences isn't going to be the answer in 10 years' time when we haven't, got Devon on the map anymore.
Or Cornwall.
If
Devon's gone.
Yeah, exactly.
Which brings us back to your specific research and why it's important. So why this research on algae? Why is it so crucial? And in fact, what does algae actually do?
Algae is like any plant, gives off oxygen, and we need it. We need, like any other plants that we have on Earth. It's been used for centuries for food. It's a natural resource. It can grow easily using just sunlight, but it can also clean up water sources. You can have problems with it in ponds that it can overgrow and stops other things growing underneath and stops light penetrating things. But it's like sunlight. We've got it. Why not use it? It wouldn't run out. It's like any other plant. As long as you look after it, it's going to be happy and healthy. So I think that's why it's kind of a relevant and an easy material to be using, because you can find it anywhere. You can also have different species that can grow at different temperatures. So obviously we're in a colder climate than other countries around the world. So maybe if we harness the technology here and do some research on it, we could then find different species that would grow better in different climates.
And who was it who came along in the first place and said, algae, it's going to be brilliant for all of this?
It dates back to World War I.
Oh, wow.
In fact, yes, that they thought, could they use it for biofuels and could they use it to feed the populations because of the lack of resources during the war? So it kind of dates back to then of when they thought, oh, could we actually use this on a global large scale?
And did it go anywhere after that?
There was a lot of research done on it, but a lot has been done for animal feeds. Some technology is done for biofuel, but it costs a lot just to get anywhere near the same sort of prices you'd get as petrol and the same quantities. So I think there's a lot more needs to be done in that side if we want greener fuels.
And who came to the idea of using it in its current form in the research that you're doing now?
I think that was a collaborative decision.
Including you?
Well, no, I wasn't on the decision panel for that. So sort of like my boss, they all came up with the idea of why not use algae? It's a plant, it'll take up carbon dioxide. Let's see if that works to clean up industry.
And are you hopeful for the future that industry will be cleaned up?
Definitely. I think if you've got the right people in the right places and government are on your side, I think it definitely needs to be implemented into industry of greening up their technologies.
There'll be people listening to you, perhaps lots of young people, thinking that not only is your work very topical and relevant now, but actually the science, the engineering, the getting out there with your spanner, like you said, sounds really cool. How would they get into your line of work?
I think as long as you like and are interested and curious about how anything works, and that's how I started, just curious about, well, why does that work? Why does this happen? Just asking why all the time. Obviously, work hard, and even if you don't get your first choices in things like I didn't after A-levels, there's still always a way of you could go around the long way like I did. It's a bit of a journey. It's like the Wizard of Oz following the yellow brick road, but you'll get to where you want to be in the end as long as you work hard and you're focused and driven to what you want.
And university study is obviously quite crucial in all of this too. Definitely.
I think it helped doing a master's after the undergraduate degree. I think that then made me decide actually I like research rather than going out into work in industry. That's where my passion was lying, and that I wanted to look and delve deeper into things of how they work. So then led me on to doing a PhD, which is even more research.
We talked about the future of industry of the planet. What about you then? What about the future for you? Where do you want to take this research first and foremost? But where do you see your career headed?
Well, hopefully, and one day I'd love to be Professor Preedy because it's got a good ring, but there's a lot of hard work in that, a lot of grant writing, got to get lots of funding in and writing lots of publications. So I'm hoping this project will get up and running now and we can, as a start, write some more papers, get some data and take it from there. Because hopefully if we do start producing some useful products, then people will sit up and think, oh, we can make money from this. I think as long as you can make money from things, I think that's where everything's going.
A window onto the nature of academia there. Emily, thank you very much. That was really interesting. To find out more about Emily's research, visit the website rice.cymru or visit www.cat.org.uk/info-resources. To find out more about this podcast and Swansea University's research, visit swansea.ac.uk/research. That's all from us today. Thanks for listening, and thank you again to our guest, Dr. Emily Preedy.
Thank you.
If you've enjoyed this episode, please subscribe, rate, and review. I'm Sam Blaxland, and that was Exploring Global Problems from Swansea University.